Okay, I'd like to welcome everybody and thank you for attending our banquet. It was really a wonderful experience. And this time we're going to do a little different. A lot of times we'll do the award first and then have the talk. But I found out that doesn't work so well because everybody wants to take pictures and shake hands and all that. So we're going to make him earn his keep first. But this is not part of the other talk. The other talk again was the keynote speaker, but what we do is when we give a Lifetime Achievement Award, we allow the speaker, gives us several of the topics, and he was graciously accepted to talk about the derivation and experimental proof of the universal force. So we want to welcome and our 2B award recipient. You can see it right over there, and that will happen later on. So I don't want to keep anyone waiting any longer, and I want to thank everybody online as well, and introduce you to Dr. Bill Lucas and his talk, The Derivation of Experimental and Experimental Proof of the Universal Force.
Thank you for inviting me to speak and to receive your award. I'm going to be talking about 60 years worth of work. However, it occurred in such a haphazard way that I never finished telling it to you. So I have organized it in a way which wasn't exactly the way it occurred with my life, but it makes it easier to understand where I'm going and how I got there. So the first slide I wanted to show is a book by Lee Smolin. He works for the Perimeter Institute in Canada, and it's called The Trouble with Physics. And there's a lot of people know that all is not well in theoretical physics, and somehow Lee Smolin has been able to communicate what's wrong, and two of his faculty or members at the Perimeter Institute have received Nobel Prizes during this time. So he must have figured out how to do something, right? And but in this book, he talks about the rise of string theory and the fall of science and what comes next. So I'm going to kind of summarize a little bit about what he had to say. That gives us a background for this talk. In the problems with modern physics, one of the problems is that we cannot combine general relativity with quantum mechanics. We have a problem with infinities in electrodynamics, quantum mechanics, and general relativity theory. We have a problem with understanding dark matter and dark energy. I have a problem with that too. We have a problem with understanding the decay of gravity and the expansion of the Earth. The standard models of elementary particles have 20 to 29 empirically determined constants representing unknown physics in an attempt to unify the different forces. Now, if I had a theory with 20 to 29 empirically determined constants to explain gravity, you would think my gravitational theory was no good. You would rather have F equals big G and 1 and 2 over R squared with just one empirically determined constant. But the other problem was string theory is not experimentally falsifiable. Why is it not falsifiable? Because they say it's a scientific method, so you can't falsify it. And the last one is the ultimate problem in physics appears to be the discovery of the universal force. And that's our goal in this talk. How do we discover it? How do you even get a clue as to what it might be? Well, there is a person who had a good idea. His name is Henri Poincaré, and he developed a branch of mathematics and natural philosophy called Metatheory. And in Metatheory, he developed and proved a number of theorems. We're going to look at 4 of them, but there's many more. And these theorems apply to many areas of science, and people do not like his theorems. And I went to the University of Maryland, where I got my master's degree, and I went into the physics library, and I asked to see the books by Henri Poincaré in which he derives these theorems of metatheory. And they were in the card catalog, but they weren't on the shelf. So I went to the head librarian and asked who had them checked out. And the head librarian says, no one. No one is allowed to see these books. I said, what? I'm not used to that. She says, not even the President of the United States or the President of the University of Maryland or the Chairman of the Physics Department is allowed to see these books. And I said, why? She said, the education framework does not allow any library at any university or elsewhere in the United States to let anyone see these books or they lose their federal funding and support. And so I was shocked. So I thought, well, no problem. I'll just get one of my friends over in France and he'll go to the library and get it. So I had a friend, Assi, in Brazil, who was on his leave for a year to go. He went to University of Paris, and I had him go to a library and see if he could get these books. And he said, "You won't believe this, but they didn't let me see them. They won't let anyone see them." And I thought, oh, why not? What's so important about these books? Well, let me go through these 4 theorems and see what you think. I wish I had the proof of these theorems, but we'll go through them. The first argument or theorem for metatheory is that no 2 fundamental theories in nature can employ the same fundamental constants, such as c, the velocity of light. Well, what theories use c? Electrodynamics uses c, of course, in its wave equation. Special relativity uses c in the space-time interval. Quantum mechanics uses c in the energy quantum. General relativity uses c in Einstein's field equation. And I show those on the screen. I don't know if you can read them very well. So that's the first argument for metatheory. The second argument, after we go through these 4 arguments, we're going to talk about what kind of solution could satisfy those arguments. The second argument is only fundamental theories can be true. Oh, well, no, that's interesting. The third argument is no 2 fundamental force laws can have the same mathematical form, such as 1 over r squared. We have the force of gravity as 1 over r squared, and the electromagnetic force is 1 over r squared. Then the final theorem I want to mention, this is not all the theorems of metatheory, there are many more. According to the superposition principle, a set of theories describing the universe cannot be logically consistent and physically stable unless it consists of only linear theories or one nonlinear theory. So if we look at electrodynamic force, it's nonlinear. We look at the gravitational force, it's nonlinear. They're both one of our R-squared forces. We look at quantum mechanics, Schrödinger wave equation, and it's nonlinear, and relativity theory is nonlinear because it has a 1 minus b squared over c squared in it. So, what is the solution? Does it give us an idea? Is there any solution that can fit this at all? Well, there's two possibilities. Possible solutions are: one, electrodynamics is incomplete, and a more complete solution for electrodynamics would replace gravity, dark matter, dark energy, quantum mechanics, relativity theory, and the standard model of elementary particles. One solution. Second solution, all the theories of modern science are false and need to be replaced. Well, if I'm looking for a direction to go, if I want to find the universal force, what direction should I go from this? Pardon? The first one. The first one. I would try to find first, the simplest would be to figure out how to complete electrodynamics better, and then to show that that replaces all these other things. So that was the goal. I didn't see that in my first 60 years for a long time. I wish I had, but I had not. And so I only arrived at after I had done most of the work to do that sort of thing. Now, if you want to know how to improve electrodynamics, it turns out that there is one man who knew how to do it. His name was Isaac Newton. And he published a book called Mathematical Principles of Natural Philosophy, or Principias, as we call it. And so what did he say we should do? He said, empirically, we should find by logical induction the minimal set of terms and precise mathematical laws involving these terms in each field of science. First step. Second step, use a complete set of these empirical laws as axioms to derive by logic a general force law by logical deduction in each field of science. Third point, predict additional phenomena from the general force law for further verification. And finally, continue the process to find the more general force laws until by logical induction, the most general or universal force law is found. Okay. So we want to look now at electrodynamics, the field of electrodynamics, and see what it is we need to do. And so if you look at the screen here, you'll see we have 6 empirical laws of electrodynamics. We have Ampere's law, which is the generalized version of it. We have Faraday's law. We have Gauss's electrostatic law, Gauss's magnetostatic law, Lenz's law, and Lorentz's force law. We have 6 laws, and guess what? 8 unknowns. But we have a solution for that. We can use the Galilean transformation because we have T and T prime and R and R prime in these equations. So, let's see. I want to give a little background information here at this point. We talked about how did we know that protons and neutrons are made of other particles called quarks. We found out by doing scattering off of those particles. And in this slide, you see the data by Robert Hofstadter, and you see that this is the proton here on top, and the dashed line is the neutron, And there are 3 segments to each of these particles, and they correspond to the quarks. And if you do it in more detail, you can find the charge on each of those, and the charge is, for the quarks, is plus or minus E over 3, and plus or minus 2/3 E over 3. And that tells us that the smallest building block of elementary particles is likely to be with a charge of E over 3. That means that the electron would consist of 3 things, and so that's a possibility. The second piece of background information is done by William Hooper, and he did this work at the University of California at Berkeley, a fairly good university, and he measured the properties of induced and static electric and magnetic fields. And he measured 14 distinct properties of these fields. But when Maxwell and his assistant Oliver Heaviside solved the problem, the simultaneous problems or simultaneous laws of electrodynamics together, they assumed that all these fields were the same. So they didn't take into account that. That's something that they missed. And then the electric and magnetic fields remain attached to their source to great distance and have tensile strength. And this is confirmed experimentally by Hooper. So we have a clue that the size of an electron is not the little point or the little top particle we have, but it's something that extends maybe a light year or farther away from where we are. So that's very unusual. Then we have another experiment we need to take into account. It's called the Michelson-Morley experiment of 1886. And in this, we were running light through water that was moving. And we were looking to see what impact there might be in terms of the ether and things of this sort. And what was called the Michelson-Morley experiment was first explained in 1886. The experiment of 1886 was explained by special relativity, but later we found there was another solution, and it was by Fox and Renshaw. And here's the results of their. They found that Galilean relativity, C prime equals C plus or minus V, fit the data, not special relativity. And so special relativity has C prime equals C. And so that assumption of special relativity was found to be false. Okay, now what are the equations we need to solve again? Here they are. There's the 8 unknowns that we have. This is the 6 equations, and to that we're adding Galilean relativity, not special relativity. And so when we solve them simultaneously using standard mathematics, calculus, etc., we get a number of interesting results. One of those results is the solution for Lenz's law. And the induced field minus the initial field is equal to these terms. And they involve 1 minus beta squared, which is v squared over c squared. What theories normally have 1 minus beta squared? Relativity, yes. But electrodynamics is not relativity theory. But if you solve the complete set of the laws, you get the results in electrodynamics that special relativity usually is thought of as explaining. But we have none of the assumptions of special relativity, of which there are 8 or 10 that are known to be false. And we don't have any particular assumptions in our empirical laws of electrodynamics, although we may find some one of these days. And guess what this is going to do? It's going to give us a ring model, Lenz's law. And so that's interesting to know. So, let's see what's next here. I think this is supposed to be a video. Oh, that might be it. Yeah. Now I'm going to show you an experiment in the fluid of water. This is in a swimming pool, and this is a dinner plate, and this person is moving it with their hand. You can see it moving, and they made 2 what we call solitons in water. You see the water is spinning around the soliton. Now, if I were to call that a particle, I would say the radius was the radius of that dark item there. That's, well, you can't see too well here. But anyway, and then if I look at the size, you can see the waves going out quite a distance from those disks that are part of a whirlpool. And so what I would normally call the size of it, which is the size of the disk, is not the size, because the size actually extends over to all the walls of the swimming pool. And so it's quite big when you consider all of that. It's kind of like a hurricane or a cyclone or something like that, where you have a funnel, but then there's the clouds and the things that contribute to that funnel that are rotating around it, and you have to take all that in account to understand what is happening. So that's what we see here, and we'll now go to another screen. So solving these 6 equations, empirical equations of electrodynamics. By the way, Maxwell and Oliver Heaviside only solved 4 of them. They excluded 2. But when we solve this, we don't use the vector potential, which is a non-physical quantity. We use the energy potential. And notice in this that we have our 1 minus beta squared terms in the potential. So we've got all the relativistic stuff that is in, and then the force that we obtain has multiple terms, 2 terms, and these also have relativistic type of terms. Now, if we compare that with what Maxwell and Oliver Heaviside did, we have here's phi, the vector, scalar potential, and A, the vector potential. And you see that they are identical. So when I take Maxwell's 4 equations, the solution, and combine it with special relativity, we get the same thing. But there's a difference, and that is there's more terms that come in the when you use the energy potential. We'll see that in a minute. So what are the assumptions of the existential relativistic Maxwell electrodynamics? It uses the point particle idealization. It uses idealized displacement current D in capacitors. It assumes action at a distance forces. It assumes only linear field effects, no lasers possible. It assumes static and induced fields are the same type of field, but we know from Cooper's work that's not true. It assumes no magnetic monopoles, and they are for sale on the internet, and many cars, including Mercedes, use them in their steering column. And then it assumes the arbitrary Lorentz gauge to uncouple wave equations to an idealized covariant form, which is what they wanted. It also assumed an arbitrary Coulomb gauge to eliminate longitudinal fields. But longitudinal fields are detected in radar and living systems, and many people know and have done experiments with longitudinal fields. And then it also uses idealized special relativity theory. So there's a lot of things that are not good about what they have and the assumptions they've made, but they got a similar result to the solution of all the empirical equations simultaneously. And if we look at special relativity, it has a lot of idealizations too. Point particle idealization, idealized inertial reference frames. It doesn't take into account Mach's principle, which means it only looks at what's local around you, not what's far away in the universe. It ignores what's far away in the universe. If the universe has a center, which it appears to do, then you have to take that into account because it can even dominate the local effects, depending on what's going on. It assumes space is homogeneous and isotropic, which means there's no central points. That means our sun can't be the center of our solar system, because that's not homogeneous and isotropic. It means that the velocity of light is independent of the velocity of the source. It assumes that the velocity of light is an idealized constant throughout the universe. It assumes an idealized notion of mass. It assumes Mach's principle is not valid. And by the way, Einstein helped Mach to find the principle. He just was disappointed because he couldn't make use of it in general relativity or special relativity. And it assumes Maxwell's ideal of electrodynamics, and it assumes action at distance forces, and assumes quantum effects do not exist. It assumes gravitational effects do not exist in special relativity. So, now if we keep going with our energy potential in the electrodynamic force, we can derive additional terms which you cannot derive from Maxwell's equation. And these terms are an acceleration term and then an R cross A, or acceleration term, and an R cross B term. And these have what we call chiral symmetry. And there is no chiral symmetry in the Maxwell version that has been combined with special relativity theory. So we may be onto something, because now we found a way to get a more complete version of electrodynamics than was done before, and maybe with this we won't need special relativity, we won't need quantum mechanics, we won't need the theory of gravity, we will be able to explain more things with this theory. So, it turns out, to get the radiation reaction term, we end up having to evaluate this integral of f radiation dot v dot dt. And when we do that, we get three terms, 1, 2, 3. Two of them have boundary conditions and the third does not. The third gives rise to what is experimentally observed as the radiation reaction term. By the way, Maxwell's electrodynamics doesn't do that. You have to have a separate theory for that. They can't predict anything related to radiation and radiation reaction. But these two terms have boundary conditions, and the boundary conditions cause them to go to zero so that the radiation term we derive is what we observe. And if we do that, the boundary conditions require that all quantities that are electrodynamic have to be made of toroidal ring structures. So that is the result of that solution. So we're making a little bit of progress. So here I show a picture of a toroidal ring. Now the white line is really the toroidal ring, not the blue and yellow and orange. And notice that it goes around the cross-section of a ring and around the circumference of the ring. And it takes 3 of these to make an electron. And we're going to find that the electron has its mass determined by the vibration of these 3 rings. Just kind of like oscillations or vibrations. And the lowest order of vibration determines the rest mass. It's the only known theory that can predict the magnitude of the mass of the electron without any fussing around. In the standard model of elementary particles, that's the most difficult mass to calculate. The Higgs particle and all these other particles they can get easy, supposedly, but not this one. Even though they have 19 to 29 adjustable constants to help them, they still have trouble getting it. Okay, so we made a little bit of progress. We can even define Planck's constant in terms of the structure of the toroidal ring. And it has to do with the radius of the ring, the radius of the thickness of the ring, and other electrodynamic constants. So now we want to look at the type of interactions that the new electrodynamic force can explain. Well, first of all, we know it can explain the Coulomb force because that was part of the solution to the simultaneous equations. But it turns out it can explain the force of inertia. And the force of inertia is the force between a charge and a vibrating neutral electric dipole, such as a proton and a proton and an electron. So, and this is the formula that we get in electrodynamics. And if we say it equals MA, then this stuff in the 2 parentheses is the definition of mass. The first definition of mass in modern science. The third force we see is the force between vibrating neutral electric dipoles and other multipoles. So here they are, the 2. The gravitational force can be derived, and this is a formula that you derive. And if you set it to equal minus g m1 m2 over r squared, then you get a definition using the definition for inertial mass, assuming inertial mass and gravitational mass are the same. You get those definitions and you get a value of g. No other theory predicts g. So you can actually write what g equals. Just take away the a1 squared omega squared over c squared and a2 squared omega 2 squared over c squared, and factor in these 2e squared over 3 pi, and you will get the value of g. And so that is very interesting. Here we actually do the calculation, and in my book that some of you have seen, Universal Force Volume 1, you have a step-by-step derivation. So you can check my math and everything. And so the results that you get for Vulcan force of inertia, which we saw earlier, this is the electrodynamic force of inertia. And this, when you define it this way, we get M1A, but we also get a second term. That term has never been in any definition of the force of inertia before. And so this is what we call Newton's second law, and the second term is just unknown. It gives rise to unusual types of motion. One of those types of motion is when you look at the rings of Saturn, you discover they're all in the the equatorial plane of Jupiter or Saturn. But when you look at the planets going around the sun, they're all tilted with respect to the equatorial plane. It's this term that determines the tilt. And what is happening is the path around the sun is not a perfect ellipse or that is tilted with respect to the equatorial plane of the sun. It is the path of the toroidal ring of that is the orbit, and you're only going around the cross section one whole rotation of the toroidal ring, and it looks like a ellipse tilted a certain angle, but it's not. It's slightly different, but it's not different enough that we can detect it with our detectors yet. So if we can get higher resolution, we can confirm this formula for the force of inertia. Now, what evidence do we have for this new theory of inertia? First of all, vibrating neutral electric dipoles radiate continuously because the charges are being accelerated as they move back and forth, and they produce the 2.7 degree Kelvin cosmic background radiation. I'll show a graph of that in a minute. And the conservation of energy plus decay of the inertial mass plus Mach's principle requires the velocity of the arms of spiral galaxies to exceed the Newtonian predicted values. And finally, the non-radial term explains the unusual gyroscope experiments of Eric Lathwaite and the modern version of Bode's law. So we're going to take a look now at some of these. Here is the cosmic background radiation. That is the data, and this is the fit. The red line is the fit. It is the only theory that can describe perfectly the cosmic background radiation. And that's the cosmic background radiation data from the COBE satellite. In the next slide, we see for the galaxy NGC 6946, we see this blue dots gives the spiral velocity of the spiral arms, and you see the orange line is the modified Newtonian dynamics predicted by our new theory of electrodynamics, and the yellow line is the Newtonian prediction, Newtonian gravity, and also general relativity predicts the same as that. So we now do not have to invent dark matter and dark energy because our theory explains that. Now that was in a galaxy, but what about our own solar system? It turns out that Pioneer 10 and 11, which we could monitor very closely, had an unexplained, unaccounted for accelerations. And these accelerations we can now plot. And guess what? Our new theory is able to predict the unaccounted for accelerations of Pioneer 10 and 11 due to the second terms that we have. So we have a further confirmation. But not only do we do this in our solar system when we do the spiral arms of spiral galaxies, we also are able to predict the galactic luminosity as a function of rotational velocity for all kinds of galaxies. And you can see the data there in our predictions. We also are able to predict the luminosity and size and the quantization of the galaxies. And so, the galaxy luminosity. And notice that there are 5 quantized peaks here, and they correspond to the 5 quantized peaks in our own solar system and places like that. So it's very interesting that we should see that similarity. And Roscoe in 1991 was the one who performed an extensive analysis of the 900 Tully-Fisher rotation curves for spiral galaxies to get all this data together. So now we want to look at gravity as the average force between vibrating neutral electric dipoles. And let's see, first of all, I think I need to, let's see.
Just hit the laser again.
Okay. Okay, this is an experiment in Imperial College in Great Britain.
This is an experiment with a spinning wheel, a rather large wheel, 13 inches diameter, mounted in a ball bearing on a shaft 3 feet long. And swing it in a circle and lift it with one hand, but only when it's spinning. First of all, let me weigh it to show you just how heavy it is. As I talk, you'll see that lifting it is quite an effort. It weighs about 40 pounds, and I can't lift it any higher than that without all the strain. So now, we'll spin it up to 2,500 revs a minute, at which point it becomes a live thing. Then I shall lift it 5 feet in 3 seconds by going around in a big circle. Whilst I'm doing it, I shall talk to you so that you can tell from my voice if I'm not under any stress or any time. I shall let go of my left hand, and holding this remote end of the shaft only, I shall lift the wheel through 5 feet, all on its own with no effort on my part. All I do is apparently just to steer it along the path that it's already decided it would like to go. Then there's the question of how you stop the wheel. That speed, that wheel has enough energy to throw itself 200 feet in the air. Did you notice that as it went round in a circle, there was no centrifugal force trying to pull my arm out sideways? Let's just do it once more to save time. We've already spun it up. So here goes 40 pounds of wheel as light as a feather. This is not a conjuring trick. This is a fact of science. Watch it again carefully. The fact about a spinning wheel, so far, everyone has missed.
Okay. Now, let's see if I get laser pointer back. Go to the next slide. That for showing that information before Oxford, Cambridge University, and London Scientific Society or something like that, he was fired from his university position. He was building the high-speed electric railroad in England, and they stopped it, even though it was started to work fine. And you now find that railroad in Japan and China by his design, and it can average 300 miles per hour and keep a rigorous schedule to the minute. We don't have such a train in America, and we don't have one in Great Britain, and we don't have one in Europe yet, although I think Germany may be working on getting one. But we can explain how that was put over his head. That's like the barbell or something that you have in a weight center, those weights spinning, and they were on such a long handle you couldn't hold it if it wasn't spinning. Only by its spinning could you pick it up and put it above your head. And that the extra terms we're getting in the force of gravity and the force of inertia are explaining these phenomena. Here is the formula for the force of gravity, and this is the actual electrodynamic force. If I write it in terms of G, mg1, mg2, etc., it comes to this force. And it's this second term that produces the effect that we were seeing. So we now have evidence for a new theory of gravity. And what is the evidence for this new theory of gravity? Vibrating dipoles radiate continuously and produce the 2.7 degree Kelvin cosmic background radiation. The cosmic background radiation is emitted and absorbed, with some escaping, causing the force of gravity to decline over time. It causes the Earth to expand due to the declining force of gravity. The Earth's angular rate of rotation slows down. That means that days, the number of days in the year decreases, and the day gets longer. And the Earth's magnetic field decays, and the moon recedes from the Earth, and the Hubble redshift law is due to the gravitational redshift primarily, and not the Doppler shift primarily. The non-radial term causes corkscrew spiraling in the motion of the planets about the sun. That predicts the tilt of orbits with respect to the equatorial plane of the sun. It predicts the quantization of the planetary orbits, known as Bode's law. Remember, according to the Trouble with Physics book, one of the primary problems we have not been able to explain is the quantization of gravity. We know it's quantized, but we didn't know how to derive it or prove it, and we could just observe it. And the quantization of all the galaxy redshifts we were able to predict with Bode's law. Okay, other evidence to support it. The expansion of the Earth from gravity decay is shown here in this map. This map was produced by Marie Tharp, and she was hired by the U.S. Navy to use the sonar data on all the trips the Navy has made in ships for 30 years. And this is a plot of the bottom of the ocean, and you can see that the splitting of the continents started up in the area near the Dead Sea, and came out in the Indian Ocean and split and formed the Pacific Ocean and the Atlantic Ocean. This gives a more sharper view of the image. You can see the very sharp, this is called the Mid-Atlantic Ridge right there. And normally they don't release this data because if you get a little more accuracy, you'll know how to hide your submarine so it can't be seen with radar or sonar. And so we didn't want them to know how to do that, so that's one reason why they didn't generally distribute it. But National Geographic did come out with it in one edition of their publication, and Marie Match also published it at one time. And I paid for permission to show this slide to you. This is the magnetic stripes taken by ships that pull a magnetometer behind them, and they measure the magnetization of those stripes we saw in the previous slide. And you can see from the structure that it's definitely an expansion of the Earth, because you have the same type of stripes on each side of the Mid-Atlantic Ridge. And finally, GPS satellites tell us that all the plates that make up the Earth are expanding three-dimensionally, and these arrows here, you can see an arrow on each side of the plate, shows the direction the plate is moving. They're all moving apart, and it gives you the rate of motion each year that we're currently measuring. So that's a further example. And then finally I have some new data, which is not in my books yet, but I'll show it to you. This is the Limestone Sea Coral. And the sea coral is like a tree, it has rings, and in addition to rings, the rings have a ripple in them, and the ripple gives the number of days in a year. This is a relatively current, it just has 365 in these days, but other coral have 481 days in a year in the past. That shows that as the Earth expands, it slows down. Just like if I go to an opera or ballet and the dancer who's spinning around puts their arms out, they slow down. And that's the same thing that's happening to the Earth as it expands. It slows down this rate of time. Okay? This next, let's see if I can hear it. This is a video by Neil Adams. In case you don't know who he is the cartoonist that created and maintains the cartoons for Batman and Superman. And I think he has been at one of the CNPS meetings or conferences we've had. So here's what he has to say.
We come to the Earth, which, well, we're again here, the way it is now. Here's our world, our planet Earth, floating in space. We will be going backward in time, imperfectly, but done in a very disciplined manner. Please notice there is no subduction, no rotation of tectonic plates, no twisting, no form fitting, no altering shapes or sizes. It would be impossible for these continental plates to fit together perfectly without this being true, and yet the upper tectonic plates fit together perfectly on a smaller planet. Yes, there have been some erosion, landslides, blah, blah, but overall this activity is insignificant. There is a kind of conspiracy of silence among certain scientists. They know, but are not telling you, that the upper tectonic plates of Earth also join in the Pacific, not partially. They join totally. You are asked to believe that the continents swim or drift about willy-nilly, bumping and crashing as if they were on a grease skillet. This is not true. The simple truth is apparently too upsetting for too many apple carts. We're now going forward in time to show how the actual growth of the Earth took place. Imperfect as the details, but the overall is nailed. Antarctica, as you see, has become subtropical. Africa, on a smaller globe, moved way downward under the globe. In fact, for hundreds of millions of years, the bottom of Africa was the South Pole. South America's tail goes under and wraps around the bottom of Africa. Then incredibly joins coast with Antarctica. 65 million years ago and more, these continents were joined, and marsupials like the duck-billed platypus roamed from Australia, Antarctica, and across southern South America and up into Africa, the platypus. Dinosaurs roamed all over this world on the upper tectonic plate because there were no oceans, just shallow seas. Here today, Antarctica is frozen over, and Australia and its surrounding islands are the remaining home of marsupials. Do you see how broadly the Pacific is opening compared to the Atlantic? This is exactly why the knee-jerk Pangea theory exists. The Pacific spread is too difficult to easily visualize because it's so big. The Atlantic spread is so obvious that a child would recognize it, but they are the same.
Okay, go back to the next slide. So we are predicting the expansion of the Earth and it having a single continent at one time. Now, when we look at the various orbits of the planets about the Sun, this is the equatorial plane of the Sun, this bottom line. And then when we see the tilt of the orbits of the planets, we see that there's something causing them to get out of the equatorial plane, and that something is the second term in the gravitational force that we derive from electrodynamics. And we're able to predict all of these tilts. So that's a very interesting thing. Furthermore, we are able to derive this formula for the period of the nth planet is equal to the period of the Sun times the what do you call the principal axis of the ellipse that we use to talk about it to the nth power. And you can see on this map, here's the Sun, here's Mercury, Venus, Earth, Mercury, Mars, I guess Venus, Earth. Then this is the asteroid belt, Jupiter, Saturn, Venus, Neptune, Pluto. And the fit is very good. And now A is the semi-major axis of the orbit, that's what it is, sorry. And so we're able to derive this formula from our gravitational force law. But that's not all. We have more data here. We have the Hubble redshift law due to the decay of the gravitational redshift. And here is the Hubble relationship. And the deviations from this line are the Doppler shifts. So you can see that, what it's like. And then when we look at this galaxy, NGC 4319, and then we look at this quasar, MRK 205, we see the Z here is 0.07 for the redshift, and the Z here is 0.006. Now, since they seem to be connected, we expect their redshift, it's the Doppler shift, to be identical, but they are very far from identical. And so what has happened is this quasar has been created and kicked out of this other galaxy. It's in the process of leaving, and it's a new system, and its gravitational force is higher than the gravitational force of the one that came from, and that causes it to have a higher redshift, even though the Doppler shift is identical. So that's an interesting piece of phenomenon. Finally, on that we have the quantization of all redshifts. If you look at the redshifts from the position of the Earth, they look like this as a function of distance from the Earth. If you look at it from the center of the universe, take into account the gravitational redshift, you find we have 5 bands of galaxies about the center of the universe, and they obey Bode's law. So we now believe that not only does this improved version of electrodynamics explain things in our solar system, in our galaxy, but it seems to explain the overall structure of the universe, and it consists of these spherical shells of galaxies, 5 of them about the center of the universe, and they're quantized, just like the orbits of our planets are quantized about the Sun. So, if we go back to what Newton's steps were, empirically find by induction the minimal set of terms and precise mathematical laws. We have done that. We've had it for 150 years. There are 6 of them, and we use all 6 to solve for a solution. We predict additional phenomena from this more general force law for further verification, and we have had a lot of verification that no previous theories of gravity could do or predict. And then we continue the process to find more general force laws until by induction, the most general or universal force law is found. And so from electrodynamics, we can explain electrodynamic force, gravitational force, and force of inertia. The other 2 forces, the weak force and strong force, has been discovered by NIST when the mass of all the nuclear isotopes has been measured at 8 significant figures. They found there's no longer sufficient data to justify a weak interaction force or a strong interaction force in the nucleus. So we have eliminated all the major force laws that are known. So our conclusion is the electrodynamic force law is the prime candidate for the universal force law because it replaces all long-range force laws with a superior force law that explains more data. Its symmetry is confirmed in all structures on all size scales in the universe. And we note that the short-range strong and weak interaction forces do not exist according to the recent NIST nuclear isotope data. So how can we summarize this force? It's, first of all, based on the axiomatic, empirical, and structural scientific methods. The current scientific methods, the existential and the postmodern, are not based on the axiomatic and the empirical scientific methods. They have a modified method that is not leading to truth. The universal force predicts the symmetry of structures on all size scales in the universe, and we find the same symmetry from elementary particles to galaxies. All forces in nature are now local contact forces. There is no such thing as action at a distance. The electromagnetic field is what contacts everything on all size scales and transmits the forces. We also find that this new theory supports the law of cause and effect, unlike quantum mechanics. It defines mass in terms of vibration of electrodynamic multipoles. Mass is not an unknown. When Isaac Newton was asked what is mass, he says, I don't know. It's a property of matter that it works when we put it in equations, but I don't know what it is. And when Einstein was asked the same question, he said, I don't know either. So that's very interesting that those 2 people were honest and said they didn't know what mass was. This theory replaces quantum mechanics, and using structural dynamics, so quantum mechanics has a physical basis, not a universal wave function, and the mysteries and infinities and everything associated with that type of approach. It replaces special relativity, just using electrical feedback effect of Lenz's law. It replaces the standard model of elementary particles, and I'm in the process of publishing a book showing how it can predict all the properties that we know of the complete set of elementary particles and no adjustable constants. The standard model has 19 to 29 adjustable constants representing unknown physics. All we have is constants representing electrodynamics. It replaces the direct quantum model of the atom. It predicts the full set of observed emission spectral lines, which no other theory can predict more than 50%, and it predicts 100%. It replaces the quantum and liquid drop models of the nucleus by the way the nuclear shells are formed. It replaces the quantum model of molecular bonding. It replaces general relativity theory of gravity replaces the Big Bang standard model of cosmology. It explains the electrodynamic origin of life on the molecular scale. I didn't have time to go into that, but the longitudinal waves and fields are associated with life, and that's another whole talk that's coming to that. And it explains the electrodynamic operation of the living cell. So cells cannot perform or live without electrodynamics. Now, I'll show you the list of the books that we have. This is the one that I had available here at the conference, The Universal Force Volume 1, derived from a more perfect union of the axiomatic and empirical scientific methods that Isaac Newton specified we should use. Then the second volume is the Electrodynamic Model of Elementary Particles. The third volume is an Electrodynamic Model of the Atom and Nucleus. And the fourth volume is an Electrodynamic Model of Molecules and the Origin and Nature of Life. We also have one other piece of evidence. We have the confirmation of the universal electrodynamic force law having what we call chiral symmetry. These terms here on the bottom all have chiral symmetry. The terms on the top are what the electrodynamic force law for coming from Maxwell's equations and Einstein's general theory of relativity would predict. They don't predict the chiral symmetry, and they don't get all of the terms of electrodynamic force. So we made a lot of progress there, and that chiral symmetry can be observed in the structure of all elementary particles, atoms, nuclei, molecules, animal bodies, plant leaves, plant flowers, orbits of the planets about the sun, orbits of these spiral arms about the Milky Way galaxy and the number of spiral arms, and then the overall structure of the universe. So that is an amazing accomplishment. Here's what the current model of the electron looks like. It consists of 3 toroidal rings. And let's see what time it is. I think it may be time to stop at this point. I had more, but it was designed more to go into life and things of that sort. And I don't know if that's how appropriate that would be for this talk. So I'll stop at this point and open it for questions and comments.
We have a few minutes for questions, comments. You have microphones, please use them. We are live on this. If you need a microphone, please ask for it.
What's the material of the ring? I know that all 3 rings come together to form an electron. However, what is the material for the blue ring, for example, or what material is for the yellow ring?
Each of the materials is made of the electromagnetic field and is a soliton of the electromagnetic field. And so, even though you might look at this and say, oh, it's a finite size, I can see what the diameter is and all that. Really, if you had all the waves that were coming out of it all the way around, you would see, oh, it's much, much bigger than that. But we just look at this and we approximate this by talking about charge in this ring going around, and that's the only way we currently know how to describe it. But it has a very long range and very large size, so that every toroidal ring and every electron on the Earth is affecting everything in our solar system. That's how long the range is.
Yeah. The new model of the electron we have there,
Yes.
would it also apply to a positron?
Yes, but the positron is not 3 rings. And the positron, the positron would be the anti-solitons. It would be making up the positron. But did you say positron or proton? Positron, yeah. A proton has a different structure. It's made of 3 quarks, and the quarks are made of multiple toroidal rings. And so it's a more complex, but it has to have chiral symmetry. And remember, in one of my earlier talks, I talked about the Greeks who knew, or thought they knew, that monads were the building blocks. Monads were probably these toroidal rings, and they thought that geometry was the key to understanding all the aspects of matter, and that's why they put in their academic academies, let no one ignorant of geometry enter here, because they thought geometry, you could never understand the universe without knowing geometry. And the geometrical structures were the most important thing in terms of understanding matter. And that we interpreted that, since these rings are unkubble, that these monads were really chemical atoms. And we did that about 1900, and we've never gone back to monads. But monads is the answer, because we found the atom was made of electrons and protons, and we found that the proton is made of quarks, and quarks are made of something smaller. And so you got all that structure in there. And in order to understand the mass of the proton and the spin of the proton and its other features, you need to know that. And then when you get to other elementary particles that decay, you need to be able to explain how the structure comes apart and what it's going to decay into. And so that is what my second book on the theory of elementary particles will explain. I've already published that in international conference in the Canary Islands, sponsored by the Spanish government. And but I'm doing more history and background of that stuff to put in the book, so that people will realize this is not new. This is the oldest information from the proto-natural philosopher named Moshe or Moses. And so that's a great, I guess you'd say, recognition of Moses. He was recommended, he was highly regarded for thousands of years for his work, and not just in Greece, in the Roman Empire, in India, many places in the world along the silk trading route were recognizing him.
Another question?
Yes.
I was wondering, so how does the magnetic field work into this? Specifically, how does an electron deflect in a magnetic field in your model?
Well, the electron has the magnetic moment, so when you have a field, it will interact with the magnetic moment, and it will produce a force. The two fields. See, since the field has tensile strength, I don't have to have a mass to affect it. All I have to have is a change in the field, and that will push another soliton around. And if I have a particle like an electron made of 3 solitons, all of them will be pushed in a coherent fashion.
Well, I mean, are things like Lorentz force law just baked into one of those equations? Is that
The
basically
Lorentz force law, when I solved these equations are vector equations. And so a vector equation is really 3 equations, or 2 if you do r and theta and phi, coordinates. So it turns out that you don't actually need the Lorentz force law, because by the time you solve the others simultaneously, you already have the Lorentz force law. And the Lorentz force law is slightly off, but very close to the true law. It misses one little feature, and that is covered in the book. And but yeah. Any other questions, comments?
Okay. Thank you very much. Just stay up there for us, and we're going to give the presentation now. We adjust some of the cameras. course, as I always say, it's a great honor for us, but it's also sad in some sense that our little group is representing all of humankind for the great science that has been going on for many years outside the mainstream. And so the way I look at this is as a historic moment for the future and the history of science. And I must say, I've seen lots and lots of models, but I will say yours is probably the most complete I've ever seen in its predictive power. And I know about your work, but somebody much closer to you and a huge admirer, even though he's been away from the CNPS for a number of years, he was really gracious to help me write what is written here today. So I will read this before we present this. It says, the John Chappell Natural Philosophy Society bestows upon Dr. William Lucas its highest honor of Lifetime Achievement Award. Having derived a universal electrodynamic force law that describes physical phenomena on all size scales throughout the universe, including refining the ring model to describe elementary particles, decay, reactions, and excited states, and also having developed the chiral symmetry of the universal force, awarded on this day, June 29th, 2018. Congratulations.
Thank you very much.
A few words, perhaps?
Well, I think it needs to be said that all of us do not accomplish great things without standing on the shoulders of people who came before us. And those people, in my case, are people like Isaac Newton, Henri Poincaré, and I consider them even greater than I myself am. I just followed their instructions and had the success that I have had. And so I think we all need to be humble, and we need to realize we depend on people who came before us, and we're not completely alone doing it all on our own. We have to recognize the work of people who came before us and realize that we're just trying to improve on it. And in some sense, you might say, I just improved a little, but it worked out pretty well. So that's the situation. And I want to thank you for your attention and for inviting me here today.